Look like some live also. I'm also live on Twitch. Seems to be good. I think this audio is a little bit too high, so let me just reduce this. Okay. So, welcome everyone. Welcome back. If you're a viewer which has viewed some of my past stream, it's been a while since my last stream, but I want to start a new one. So just a quick update about the November experiments. I'm still writing some description for the YouTube channel, and I'm still finishing and polishing the Git, so it will be released soon. I hope this weekend. In fact, it's a lot of work, so I didn't plan to work. I made a lot of retakes, so I didn't plan to make all these retakes, but hopefully it will be released soon. So yeah, what's my my objective tonight? So let's read a little bit this. Okay. So what's the objective tonight? So few months back, when I was working on a project based on processing, I wanted to explore a way to bring GPU instances into, yes, this is this one. I wanted to bring GPU instances into processing, so I managed to make this project. So basically, GPU instances are duplicating the mesh on. It's duplicating the mesh directly into the GPU in order to avoid drawing it a lot into CPU side. So it's drawing mesh directly inside your GPU, and you can also make some animations, change the color, change the shading, etc., using shaders or compute shader, etc. So I work a lot with GPU instances, and all my November was made with that. But a few months back, I wanted to learn about that inside processing.org, because processing does not support natively GPU instances like Unity, and I wanted to explore that. So I made this quick repository showing how to create a custom vertex buffer object in order to create your own GPU instances. So this was the main idea, and during this exploration, I've made this project which is named SurroundedByNature, where you can see it's a lot of instances of flower which grows on top of a mesh. So it's really simple. Basically, we only play with the scale of the shape, and basically we play on the scale on the x and z axis only in order to get this kind of growing system, and not having some kind of uniform scale, but you can make a uniform scale and also rotating everything, etc. So I made this project, and this is real time into processing, and it has a lot of post-process DOF and ambient occlusions, etc. Everything inside processing. But lately I need to push this project further, and I want to create a full 360 video for that, and it can be really painful to make everything directly into processing. So my idea, in order to have more, to be able to tweak easily the value and to change the texture and everything, my idea is to port this experiment directly into Unity. So that's the main idea. I think I will be able to do that. I think I will be able to do that really the same thing and by with using the same system as my Boston study experiment. So basically, I will use the draw machine instance in direct, and I will use the compute shader to control the scale, etc., etc. So I would need different things for that. So first of all, let's create our project inside Unity. So as always, I will only work with Unity in a legacy mode. I will not create an HDRP or URP project because it can be a pain in the ass working with the URP and the SRP in general, especially when you use instances. So I prefer to stay on legacy. It's well documented, so that's could be good. So let's call this surrounded by nature. This would be a Unity project. So as I already have the surrounded by nature folder in my dev location, I prefer to identify it by the Unity elements. So I would also need, I think, the assets for this project. The assets are quite simple. Where are they? They are here. Let me just show you. So here it is. No, this is my Unity folder. Plant growing. So this is for this one. So I have this one, and I think I have a simple terrain here. So I have a lot of different kind of terrain, and I don't know which one I've used, but okay. Okay, so let's use the organization we've had when we made our stream, so you could see everything. Let me also get my lighting settings. Okay, they're here. Okay, inspector, project, perfect. Time for a cup of tea. So basically I will need different things. First of all, I will need to import my 3D model, which is a simple one. I think I have here. So where is it? ICO. I think it might be this one. So let's check the processing project. Yeah, this is the elements, but where did I load my file? Custom frame buffer, init. Okay, so I use this one, and I use an object called plants. Look like this one. Seems good. Seems pretty good. Okay, let's import this one. It seems we also use the Terrain 2 LP, which seems to be, I think, a low poly version, but I don't know why. Number instance, triangle. Where did I put my gravity? Where is my gravity center? Yeah. Oh yeah, I think I've made this. Okay. Yes, this is one. Get A, get normal. Set vertex, okay. Okay. So yeah, let's import also this object. Maybe I will create a new folder. Let's call this 3D models. Yeah, why not 3D models? So I could put everything here. So here are my plants, and it has 2035. I think we can reduce a little bit later. We will see it later. And I have this mesh which seems to be triangulated. Okay. So basically, okay. Oh, nothing. Okay, let's call this, rename this surrounded by nature. Okay. So before working on the lighting and everything, let's just put the terrain. Okay, so this is my terrain. Yeah, we see this, so it's okay. Seems good. This is the plant, which seems to be woohoo too big. Let's reduce this plant. I think 0.1 might be too big enough. Too big again, too big. Let's reduce by a half of this. Enough, too big. Again. Starting a little bit big. I think 0.01 might be the tricks. Okay, so this would be the size of our elements. Let's this by our ground. Seems great. So I will need various things. First of all, I will need to retrieve the vertices of each point here. It might be interesting also to retrieve the normal in order to orient the shape and everything like that. Okay. Let me think. Okay. So yeah, first of all, let's retrieve this. You know what? Let's break the prefab completely in order to get on the ground. Okay. Let's create a new folder. This would be our scripts folder. So I think I will check. My starting point will be to take the same my Mixamory controller I've made, but with a little tweaks. So the first idea is to retrieve the vertices and the normal from the mesh and having something like that. So let's create here a new script. Okay, and let's name it mesh mesh reader. Okay, so this would be my controller. Okay, that's okay. And this is my mesh reader, and basically the mesh reader will be a simple script. Let's get rid of everything. It's a script which will be a bridge between the mesh and the GPU mesh controller. So it will take the ground mesh, read the vertices, read the normal, and then we will be able to retrieve this value. So let's create a new variable. It will be public game object based mesh. Okay. Then okay. Then we need also a public, but we don't want to show it in the inspector, so we would need various elements. So let's take a list of vector3, which will be our let's take only one list, it might be better. So a list of vector3, which will be the vertices. We need the same here, but it will be, so I need the normals. Okay. I think okay. Okay, so let's start with something really simple. Let's implement this by saying that this is a new list. No, we will create them later. Okay. So private void awake. No, let's create directly the element. So public. I will create a struct, it will be better. In order to handle everything. Okay. So get mesh that new list of vector 3. Same for that. So I think the idea is to get the mesh. So yeah, the idea is to get that. I don't need the UV. I only need this, so I only need the mesh. So first of all, let's create a new mesh. Then let's say mesh. No, not create a new mesh. Let's directly create. Get component mesh filter dot mesh. Okay. So look like I think I've made a mistake on my struct. I don't need this. If I don't have a parameter, I don't need to set a constructor for that. So then I could say that mesh data mesh data dot vertices is equal to mesh dot vertices. So mesh data dot normals will be equal to mesh dot normals. Okay. And void compute mesh data. Okay. I don't remember the way, but I think there is a 2 array, so yes, this is it. So that's 2 array. Oh no, I'm converting, so it would be a 2 list, I think, in order to convert as a dynamic list. To list accepting first arguments. Array to list. Yeah, I need to use in link. Okay. Let's add some debug here. So private void under gizmo if mesh data is strictly different than null. Okay. Else compute mesh data and then for each vector 3 vert inside mesh data dot vertices small dot color dot all color dot red, not green, let's say a green one. Okay, you know what, let's draw some cube. Okay, so gizmo dot draw wire cube at vert, and I want to say vector 3 dot 1 multiplied by 0 1. Let's try that. No, let's say if this dot vertices is different than null. Okay. Gizmo, I forgot the as value. Okay, and now I don't need this one, excuse me. Okay. I might made a mistake on the draw gizmo. Always forgot the S value. Okay, not an instance of an object, so okay. That's the idea. So now I have all my little elements here. Okay. Let's replace this for loop for something like something more simple to use. Okay, so int I equals 0, I less than mesh data dot vertices dot count and I plus plus. So vector 3 vertice equal to mesh data dot vertices dot high. Let's create the normals, ortho normals, and this would be the null value. Okay. Okay, this is my normal, not a problem. Multiply this a little bit. So this is okay. course I forgot the float value. Okay, so this is what I want. Next, let's put a little boolean into it. Make bool show debug equal false as default. Let's say if show debug, and then let's add all this little guy here inside our okay. So this is the mesh reader, it's ready. So now we can create the GPU mesh controller. Also it would be inspired by other so yeah. So basically we need something else, because if I move my mesh now, you can see that my vertices does not following this. Another thing that if I rotate this, my vertices doesn't change. So I basically need to take the transformation matrix from the game object and add this to my mesh data in order to be sure later in my GPU mesh controller that if I make a change on everything will scale up or scale down, everything will rotate, everything will move. So if I say something like that, I would need to have the vertices on the right position. So this part is quite simple. We only need to create a transformation matrix. So let's get that. So public matrix. So the transformation matrix is basically, so if you are familiar, if you know Unity, if you yeah, matrix 4x4, let me just think about it a little bit. Get TRS, oh yeah, that's fine. Okay, so if you know processing, matrix 4x4 processing, or Unity, or basically any 3D transformation system, basically the transformation, the TRS, the transformation matrix will handle the translate, the rotation, and the scale. And in order to do that, I only need to return a matrix 4x4, which will be .trs, so Unity can handle that for us. We will need to pass the game object, I think. Game object go, and now we will fill that as the go.transform.position, go.transform.rotation again, and go.transform.local scale, I think, local scale. Okay, then I could say mesh data dot trs, and I would need to add that here, public matrix 4x4 trs. So it would be simply get trs of the base mesh. Yeah, made a mistake here, so I prefer to use that, yes, with a lowercase at the beginning of the word. Okay, so now I have my TRS. Let's check if the code is broken. Yeah, not set an instance of an object. Oh yeah, I think because I changed this, I don't have my game object here, so now it might be okay. So let's say if we don't want to break this, if this is strictly not null in order to be sure to have everything we want. Okay. So now I can multiply the vertex equal basically of the multiplication of the vertex by the matrix. So matrix 4 by 4. I don't remember how to multiply this in Unity. I know in HLSL it's the mul system, but I don't. Position by this matrix, transform the position by this matrix. I don't remember which is the point. Yeah, I don't remember which one of this. This one is faster, I think. I only need this. Yeah, let's use this one. We only need to use the transformation matrix, but not the projection one. So yeah, it would be the vet here, and of course this would be this.meshData.trs. Okay, so now I could move the mesh or not. No, I cannot move the mesh because I need to retrieve, to update the transformation matrix every time. So I need to update this. So let's create a new function, public void update TRS, and then we could say something like that. And now if I want, I could say before that, let's update the transformation matrix to be sure. And now it's moving. Okay, so my points are basically set everywhere I want, and if I scale this, the scale is okay, and if I rotate also the object, it's look okay, but so I think I would need yeah, as you could see, the normal is fixed, so if I want, I will need to rotate the normal as well. So if I want to rotate the normal, I don't think it would be necessary. I've tried this on another one. It's certainly for the debug system, but as we will use the normal only one time, it will not be necessary. Okay, so we have our basic system now. Let's get to the next part. So the next part would be divided into two little scripts, like in my body study experiments. We will have a GPU mesh controller at first. So the GPU mesh controller will handle the all the GPU position, etc., etc. The GPU instance position, and also the I will make another controller which will be basically the system, which can be which will be easy for me to make a bridge between the GPU mesh controller and so a global controller. So yeah, it would be better. And I think I could use the same. I think I could use the same GPU mesh controller at first as the one I've used on the other system. So I think I would take this one. I will need to make a quick update in order to add some various things, but okay. So I will not go in detail into the GPU mesh controller because I've covered this part during all the Cutvember experiments, so basically I will not rewrite everything, it's not necessary. Okay. So just to make a quick refresh, also for me, let's read a little bit all the elements we have here. So we have the max instance, which is basically the number of instances we want. We have a word because sometimes when our objects are moving, we need to spawn them on different positions. We have the mesh, which is the mesh used for the instances. We define if the position taking a random vector on the skin mesh or the index. So yeah, if you want to take a random vector or not. It was especially useful if you want to use less or more elements than on the other side, than the base mesh. Okay, let me think about that. Min scale, max scale. This define the range for the scale system. This is the model description because the scale and the max scale are multiplied by this vector if you want to have some ununiform scale. This define the rotation, this use the normal direction, okay. This define the materials, this define the color. Mesh property, we have a pose list, we have the normal list, so this is what we will use. We have the compute shader. Float save time, yeah, because I made something like a pose system, so yeah, I've used that. And this is a 3-state value, ref transform property, TRS properties. Where did I use that? Okay, yeah. I will need to get the transform property from the mesh in order to be sure to handle the word. So when I've made a recheck of my body experiments, I've tried to update the word based on the size of the mesh. So I would need to, I have a quick snippet to copy paste into my mesh reader. So this is the gravity center, TRS rotated gravity center, this is okay. I don't remember, I think the TRS property might be something custom, I think. Okay, then we set the buffer, the word, and we bind the data. And this is the base system, and we use something with a translator, rotation, a scale, an origin scale. We need that, we will need that. We have the color and we have some data, so okay, and then we bind everything. We also bind the data to compute shaders, that's okay. Compute disable on enable, okay. I don't remember, I don't think I have an update here. Yeah, everything is called directly from this. Okay. So yeah, we will use this one. I wanted to make a quick modification this because I need to create, to bind the transform property. So let's create that. Public transform properties. Oh, it's okay. Get transform properties. You know what? Make something like that. And I will change this one. Okay. So basically, in order to get the transform property, we take the TRS, which is the TRS of our game object. So base mesh dot transform, is that, yeah, base mesh dot transform. The bounding box and the gravity center are set to 0. We check if we have any child. So mesh, and this is a mesh filter. Then we can so add this to our structure. TRS props, and this will not move, so let's say to that dot TRS props will be equal to get transform properties. We need to change, I don't need the index. Yeah, I know that. Okay. We use another thing. Let's import another script I've used on the body study, which is the data structure, which handle all the data, all the structure we use for the GPU mesh controller. This was the first one: transform, rotation, scale, origin, scale, data, and color. So this is what we used. I made another one here, an extended, and I don't know which is. Yeah, because I set the original position. This one was using the physics. Okay, so goodbye. We also need to add to use the com.bourgeot.lab, I think, if we want. So we will mesh tag, and mesh is already used. Okay, so I think I nearly make everything I want. I just need to have a new controller now. I think I could use the same thing, but let's be sure. I think I will need to retake some of this, but controller, okay. Is mesh, I don't need that because we don't have thing like that. Now it's a mesh reader that we use, so let's use that. Mesh reader, and this is our mesh reader. Okay. Let's call it init and then update vertices, or we can call directly into the update. No, let's update vertices. Okay. Next, this become that. This goodbye, this become that, and this is a goodbye. Okay, so it's not a Mixamo mesh controller, it's a mesh reader now. And for doing it, the mesh reader will need to compute the mesh data. And the pose list would be basically this dot mesh data dot vertices. This is mesh reader dot mesh data dot normals, because we need to bind the normals to the normals of our GPU mesh controller. GPU mesh controller. The ref transform, I think it's a transformation matrix. No, it's a transform. Oh yeah, this was the transform of this. So let's say mesh reader dot base mesh dot transform. Okay. And the TRS property is simply mesh reader dot mesh data dot TRS props. We need to bind also the vertices. I don't need to bind the vertices, we will not use them. We only spawn everything, but we will not use, but we need basically to bind the TRS, so of course I need to say mesh reader dot mesh data dot TRS, and then we compute. And when we update the vertices, I don't need to get this, but I need to get mesh reader dot update TRS. I don't need to bind that, but I need to bind the mesh reader transformation matrix. So this could be our way to handle this. So mesh data Mesh reader.mesh data is inaccessible. Why? It's a public element. Oh no, it's private, it's not public. So yeah. Okay, now it's public, so now we can handle that. What? Inconsistent field mesh data is less accessible. Okay. So now we have a controller and we have a GPU mesh controller where we can set everything, and we need a compute shader. So for the compute shader I will create everything. So let's create our compute shader, but let's feed a little bit our system here. So first of all, I cannot read the mesh data here. So here, so I've make a quick test in order to say, let's say play to check if we can see if everything is running and if we don't have any mistake, but it seems we have some, but it seems to be really simple. Yeah. So value thing first, let's disable that, and you will see we will have some. Okay. So Unity said we are not allowed to access the vertices of the mesh because it's not readable. Also, we cannot access the normal, it's not readable. And then we have unassigned reference exception to the compute shader. That's normal. So yeah. What's happened if I want to read the mesh? Okay, let's move this one. If I want to read the mesh inside in the mesh data inside Unity, I will need to set it as read write enable. So if I don't do that, the mesh will not be accessible. So the mesh data will not be readable. So I could not read the UV or the vertices or the normal on CPU side. On shader side, you will have basically everything you want because you're on the shader. So, but if you want to manipulate on GPU side, the data will not have it. So yeah, apply that. Okay, let's remove that. Mesh default instance is readable. Okay, let's continue that. If I said this, let's say shared mesh, so as Unity is suggesting. Okay, so now let's create a compute shader. We'll create a simple compute shader, so I will need different things. First of all, I think I will need some kind of description system. Yeah, I will reuse this one. So this, oh, I could write everything. So yeah, let's create a compute shader. I'll write everything inside of it. I only need one compute shader. So okay, compute. What name? Growth, noise growth. Yeah, it's based on the noise, so basically it's a noise growth. Okay. So now I can say okay, so this is my compute shader. Let's get rid of this part. So the kernel is the name of the function, and let's get rid of all these things. First thing first, I need to take the same structures as we have in the GPU mesh controllers. So we use this data structure, which is basically, for each instance, we have a custom structure which has the transformation, the translation matrix, the rotation matrix, the scale matrix, the origin scale matrix, a data in order to handle various value, etc., and a color. So basically, I will name this as the same. And let's say it's a struct, of course, of the mesh properties, and it has a float 4x4, which is a transform matrix, which has also, there's a lot of 4x4, a lot of matrix. So this is the rot matrix, the scale matrix, this is the OSC scale matrix, origin scale. We also have a float 4 which handle the data, and a float 4 which handle the color. Okay. Then we have various things. First of all, we bind a read-write structured buffer of this data, so of these mesh properties, which is name properties. So I'll keep the same name as all the value I already have here. So here I have the mesh property buffer, which name property. So I said this. I have a vector which name is word. I also have some value which is the time, the max scale, the min scale, and the model description. So I basically need to reset all these things. Also I have a transformation matrix, etc., etc. So the word, the model description, the min scale, the max scale, the transformation matrix, etc., etc. Let's start with a one dimension compute shader. Okay. And let's start with something simple. We will display everything on stage. So we will retrieve, of course, the transformation matrix. Okay. Which is, let's get its name property at id.x.tr_mat. And I could change the name for each of the matrices each matrix I need to retrieve. Let's retrieve all the data for now, just to be sure. Woohoo! Okay, and at last a simple float for the data, same name here, and for the color. Okay, perfect. first thing first, I need to, if I want to update the position of my shape, or maybe I want to make a simple rotation of the world, for example, so I need to apply the transformation matrix, the TRS, to the to all the position. So let's say float for position, which is basically the last column of our translate matrix, because the translate matrix is a TRS, so it's this one. Okay, so I need to take the last column, so it's float for TR mat 0, 1, 2, 3, so yeah, 0, 3, 0, 1, 0, no, 0, 3, line 1, column 3, line 2, column 3, line 4, column 3. So yeah, this is it. Also now I could say this is 1, but let's get that. So now pose will be basically equal of the multiplication of the TRS. Okay, so we will multiply the transformation matrix to the position, and now I will create a new transform matrix. Okay, let's say translate, which will be equal to float 4 by 4 0, 0, 0 pose.x y z w, and we will set the property of Tiamat to transform. Then we will get the scale and everything else. But if everything is correct, uniformat kernel compute. Where did I make a mistake? I forgot a semicolon here. Oh no. Yeah, this one is here. And its name is translate. Okay, so the compute shader is okay. I now need to create the shader. So again, I will use the same thing as my body experiment in order to be able to quickly iterate. So I think this is the simple vertex. I need to use this one. So we use this mesh property here. This is the inverse rotation matrix in order to get the rotation correct. Color, props, data, position. Okay, so I will use this one. Let's call this folder shaders. Open. Show in Explorer. Okay. Okay, I use that, and I would need so I would take the first one here. Okay. Okay, so flower, and I will name this flower shader. why I can't. Here it is. Okay, I don't need this one. So yeah, I'm taking the first shader I've made for the body study experiment. All the videos are accessible on Twitch, and also it will be available on YouTube in maybe a few days, maybe tomorrow, but soon. So yeah, basically it's calling the simple vertex and the data structure.hlsl, but I don't have the data structure.hlsl. So yeah, I need to create this file. So I will create this. So basically the data structure.hlsl is just a file which handles the structure of my instances, so it will be shared between all the shaders. Okay, so its name is data structure. Let's create something new. I name this compute shaders. .hlsl. Okay, so now it's in the proper folder. Okay, that's okay, it works. So let's take a look at that. So we have a simple vertex. So the simple vertex is basically simply passing the values from the structure buffer to the input, to the output, sorry, from the vertex shader. So basically taking the ID, the color, the data, and the position, because it could be interesting to use the position. We also have the word reflections. Okay. Okay. Looks like okay for me. So let's create a new folder. Let's call this materials. Let's create a new material. This would be our flower, and we will put our shader into it. Okay. On my controller, I would put this here, and let's say something like that. So let's start with 1000 instances, a word of 10 by 10 by 10. Our mesh would be our plant. Let's say random. Let's have a mean scale of 1, a max scale of 1, a model description of 1, 1, 1. No random, we will use the normal direction, and let's test this. Access the mesh. Is readable, index was out of range, must be non-negative, and size of the collection, and properties at kernel. So here I have something bad happening. Clone properties kernel is not set. Yeah, of course it's not set because it didn't bound everything. Out of range, must be non-negative and less than the size of the collection. I think this is this part here. I don't know why, because I've put the ground here. Receive, contribute to GI. Let's see these two statistics. So yeah, I need this, but the terrain is set to read, write, enable. So why? Yes, I think this is this one. No. Okay, it seems it might be a poem. Okay, seems okay to me here, but look like we have only one flower. This is strange. Okay. Terrain is okay, but here I cannot push the value. Why? Might come from the controller. I think we've passed clearly here, so so if it's not here, let's check each step. So remove this part. Let's not change anything in the compute shader. Let's just try to draw our meshes directly in the correct position. So right now it's not on the correct position. The mesh is only here. So this is my world. just to check everything. Okay. So if it's not happening here, it's happening in the GPU mesh controller. Let's check this. Debug. Okay, we are clearly have the position here. So this is okay. So look like what? The data structure look like the same. TR rotate percent data. We are clearly using this. So look like a shading problem. Look like anything is enabled. I don't see any mistake. Why does my data does not change here? Main text, internal. Do I need to rewrite everything? Clearly not I want, not that I want. Why? The mesh data has been computed, so it's not a problem. We've seen that everything is passed correctly, because if I say something like, let's say, we have the data here. We set the buffer, so it's not a problem from here. I don't have a vertex here. I can include this file. It's in the shaders folder. It's not in the... okay. Okay. Look like we have our 20 elements on difference. Okay. So now we can say we want 1000 elements. I don't want some randomness. Okay. Okay. So basically we have the system, in fact. Okay. And if I want to have more, so the main problem is if I want to have more elements, but let's first of all reactivate this and think a little bit about the project right now. So we have the base system. Okay, we have all our instancing which are spawned directly on our little elements. So this is clearly what I wanted to achieve. I need to set the growth animation, etc., etc. But basically, we have the instancing spawn, the instance spawn on the mesh and following the direction of the normal. And if I want, I could set some. I could change. So I could set some randomness into it. So it seems we have a lot of elements. Also, I think if I want to change a little bit the transform, no, it didn't follow the transform. Why it didn't follow the transform? Did I make a mistake somewhere on the controller or not? It looked like we hadn't, but we pass here, but yeah, I need to reactivate the compute shader here in order to have the full based system. And everything has disappeared. Why? I think the one value from my element here might be the problem. So let me just say that to be sure. No. Okay, so I think I've made a mistake somewhere. if I say something like one, 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 it would be at 1 or not? No. Clearly it has disappeared somewhere. I don't know why. Not somewhere. It has not disappeared. My transformation matrix is false. Of course it's false. We need to remember how the matrix transformation works. So it's the rotation multiplied by the rotation multiplied by the scale matrix at last. Okay. And each matrix is a 4x4. And basically the rotation and the scale are handled in this component, so in the diagonal of the matrix. So if I set this value to 0, I'm basically this is the scale here. So if I set everything to 0, basically I'm just shrinking down my my instances. Okay, that was the mistake. And now if I want to change that, you would see the TRS, but everything is moving a little bit. Why? Yeah, because I'm taking the position. I'm updating the position, so I would need to change this. I'm taking the percentage and again and again and again and again. Yeah. I would need to add a new value into this, which would be origin Tiamat. Okay. To be sure. Origin Tiamat. Okay. So this would be that. So right now I will not need, let's keep everything right now. This one is not useful right here. So I will need to update my data structure in order to add a new value here, and it would be before that transform rotation and scale, origin transform, origin scale, and then it would be here. I would add some OTMAT. Also I need to change in my compute shader my structure here in order to put an origin Tiamat here. Okay, and in the GPU mesh controller I need to push here into the Tiamat, the origin, excuse me, the origin Tiamat, and you translate at position. So I will take a value which is not updated at each loop, and I will multiply by the transform, the translation matrix. So this could be the solution if I didn't make any mistake. It will be the solution. Okay, working. As you could see, I can now move my elements and all the instances are on the same place. So great. What we need to do now, use some color. I think I will use a ramp. I think I already have a ramp on my processing sketch. So yeah, we need to scale everything, make the animation, scale everything on the X and Y axis. I will need to shade everything, get the light working, and this will be all, I think. Put a camera and oh, and I would also need to add some GI. This is really important. Okay, I would add the GI last, when I will try to work on the other part. So let's set the terrain as static, so it will be baked. Okay, so let me quickly take some notes in order to see what we need to do. Whatever you think I want to do in order to achieve the retake of this little experiment. So first of all, let's go back. I need to remember if I post it on my profile. I think so, but I'm not sure. Did I? Yeah, it was this one. So this was the experiment, and this is the one we tried to retake. I will change a little bit the colors, I think. So yeah, we have the growth we want to make. We want to add some lights. We want to change the. It's not only the lights. We could we want to. Yeah, sorry. I want to add some lights. We will have some shadow, because in this one we don't have any shadow. So I want to make the growth. So let's put that here. The growth. Okay. We need to have the colors evolutions, because it's evolving the noise evolutions. So the growth, the color evolutions. Okay, and I think I would make on 2 noise the color evolution. It might be more interesting. I need to have the shading, the lights, and there is another thing I want to put. It's to add some global illumination. So I will need to set my light probe and my reflection probe. So this will be in my elements. So this is on the compute shader. This is on the shader, okay, and CPU also, because light probes are on different parts. We also have some post effects also. Okay, and so the shading, the lights, the global illumination, the reflection probe, the post effects, the growth and the color evolution, so it's okay. And as you could see, all my elements was a little, there's some little randomness. So here I have some grid based system, but my elements are basically here on a shape. So I think I've used an iris. So how does the iris elements look? I think the iris is used in order to push the element. Let's see. It's the element called S. So this was the experiment. So if I say S, yeah, okay, so this is the base mesh. Okay, So this was a high-res mesh. Okay, not a problem. But we also have another element. It's F, which doesn't seem to be working, but okay. In the init, I also have the base shape. And how did I work? That's how I make a little randomness into it. So yeah, so add some randomness. And this is clearly interesting in position. So yeah, what's happening here? It's when I on processing side, when I took the on processing side, when I took the base shape, I only I take the triangle, compute yeah, that's fine. I take a triangle and then I compute, I take a random point on the triangle. That's how I've used that. I make something like that. For each of one. Let me think. I'm not sure if I want to do that right now. I would need to take, in order to do that, I would need to retrieve, where is it? Let's say mesh. Vertices, for example. So this is the vertices, this is the normal, but I would need to take the triangle, which are there, array. I could use that. I could simply take that, taking the triangle, pushing the triangle into the mesh data, changing my GPU mesh controller in order to not getting the position but computing a random position on the triangle. So I will need to take the triangle, but I would not be able to take yeah, it would be I multiplied by 3, so I would need to go randomness. Yeah, I could do that. And it's really important, of course, because of that. So let me show you. I would need to, okay, this I would need to take this here because I will check everything. So yeah, right now I have everything here, and as you could see, first of all we have some kind of a grid, and I don't want to have a grid. So first of all, adding some randomness is really important. Another thing is I could put a random point on different, take a random point, for example, around the vertices, but it will not be accurate because, as you could see, if I take a random point on the sphere, my flower will not be will not have its base on the ground. So an idea could be, for example, taking the tangent of the mesh and march along this tangent randomly. It could be interesting, but again, I don't think it would be good enough in this example. because I might march too far, or also I might march in the same direction for all the instances. So the best idea would be to take the triangle. Okay, so I think I would simplify a little bit the mesh, but I'm not sure. So it would be to take the triangle and take a random point inside of this triangle. So I think it would be the best. So yeah, let's start doing that. So flower, simple vertex for now, this is not necessary, and let's only focus on these three guys here. So let's add a new thing into our little guy here. This would be a public list of int, and this will be named triangles. Basically the triangle array from the mesh are simply the index of the of each triangle. So the first triangle we have a vertex 0, 1, 2, and the second triangle we have the vertex 1, 2, 3, etc, etc. So it's avoiding the mesh to having the same to repeat the same vertices over and over, and this is why the vertex array has only unique vertices. So now we can take the triangle, and the triangle will be of course the same as this, so this and this. Okay, so now we will need to change a little bit this element here. So I will need to add this to our little guy here. So here's a new public list, which is our triangle. It's also hide in inspector because I don't want to see this as a parameter. Okay, and that's okay. I think this is this might be good. Okay, so in the controller I will need to push this into, so the triangle into this. Okay, so now the controller is taking the mesh data and pushing the mesh data into the GPU mesh controller, so that is okay, and now everything will be going here. So I think this is, so now we need to take everything will change. So we need to take tree position, so we need to retrieve tree position, okay, into the triangle array. And let's be sure I'm trying to think about the so for example, if I want to go over the proper value, it would be I'm trying to think about it, but I'm not sure, because we have some duplicating index, so I'm not sure. Let's say int i0 would be, for example, index multiplied by 3 plus 0. So this is the first index. Then the second point for the second point on the triangle would be this multiplied by 3 plus 1. and the last one would be this. Then I could have position 0, position 1, and position 2, which would be this, and this into the triangle. I0. Okay. Int theory index 0. Okay. Theory 1 and theory 2. Index I2. Okay. So theory 1, theory 2. Okay, 1 and 2. Okay, so now I could take a random position directly into this, so let's take this. So let's say float. I will take the same system I've made, so I'm taking 2 random value. So this is the random dot value. I will take 2 random value R and S in order to choose between A to B or A to C. And if so, basically I need to go from this and changing over that. R plus S is less than equal dot 1. Then R will be equal to 1 minus R, and S will be equal to 1 minus S. Okay, so this is a way to avoid not taking the good sample. So vector 3 AB. Wow. Okay. Is equal to vector 3 dot sub. I think I have a sub or a subtract. Let's check. Vector 3. Oh, there is no. Okay. I thought there was some static function for the vector 3, but doesn't seems to be. So okay, so it would be position 0, position 1, sorry, minus position 0, and vector A to C is basically minus position 2 minus position 0. Then vector 3. Now the position, I'm really not sure if it will work, but let's say this would be equal to position 0 plus AB multiplied by R plus AC multiplied by S and this could be our position. Let's check if we made any mistake. Or yes, namespace int is not be found, so int like that. Okay. Seems to be okay, but not perfect. Okay. Why? Why it's not perfect? It's not perfect because I might have a lot more triangles and vertices. So of course I'm not taking every triangle right now. And as you could see, it's not clearly not perfect. But something interesting. First of all, we can now have a lot of elements and they are clearly purely random, so it's okay. But something is not good. What is not good? And yeah, I didn't set as random, so this is okay. But that I think I will not get that. I think the things more important is to say okay. I forgot to say. Yeah, I sampled the index here 0 to the count of the array. I sample it on the vertex list, which is not correct because I have a lot more triangles than vertices. And if I want to be sure to be able to sample here, to go to the first one, second one, etc., 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 I will need to divide this by 3. I think. No. Out of range. Oh yeah. I need to divide triangle count by 3. Where is it? Is here by 3 before taking the -1. Not a close one. -2 maybe. Oh my god. Oh no, it's correct. 0 multiplied by 3 plus 1. Where is that? But why? Index sample between random value and norm y. It's not random, but here it seems I have a number bigger than what we have here, so why? Let's go back to the mesh. I think the mesh handled the solution. So what's the mesh have? Vertices, vertex, triangles, array containing all the triangles of the mesh. 0, 1, 2. For me, this might be okay, but 0 multiplied by 3 plus 0, 0, 0 multiplied by 1 plus 1, 1, 0 multiplied by 3 plus 2, 2, 1 multiplied by 3 plus 0, 1. No, 1 multiplied by 3, 3 plus 0. So I'm moving away from this, so that's okay. Index out of where was the index out of range? On which one? Is it on the triangle, or I need to know which one? No. So if it's here, this is this, which is not correct. Look like triangle is not set, or what? Let's take less value. Zeros. Okay. We still have an error. Index was out of range. Must be non-negative. 0. We still have an error here, even if we have that. Oh, of course. My problem comes from the normal. Let's quickly change that. Okay, so this is a TMP. It's not on this little guy here, but okay. It's here. I need to push where I have some index. Where do I have some index value here? Yeah, I've pushed the index here. because I needed it, but right now in the data I don't use this value, so let's say 0, and let's say this is 3. This could be a solution or not. Okay. We have some flower. Where did we have some flower? Let's say here. Look like the randomness seems to be working. Yeah, the randomness is working. So if now I think I want 1,000 of meshes, it's okay. And of course there would be some, we need also to change the value of the rotation, because it's taking only the normal. So now we have sample a random point, okay, on the triangle, but we also need to take the value of the interpolated value for the normals, okay? So it's basically the same thing here. So I would get rid of this part, so that is okay. Okay, so this is okay, and this is the position. And I would need to say the same thing here. I need to take the normals for each of them, okay, into the norm list vector, and to take the interpolated value, so I would name this n, and I would say normal 1 and 2. Okay. So normal 0 and AB multiplied by her and AC multiplied by S, and this could be our new normal. Okay, looks a little bit better. It's following the ground. If I say shaded, it's okay. Okay, looks great. Next, let's add more and more elements to check. And we have a lot. In the shading we could maybe add some wind into it too. Okay, so let's focus on the growth right now, and I think I will finish it later, but let's focus on the growth. Okay. Oh, I have one outside which is quite strange. This is quite strange to have some of, oh yeah, I know why. Okay, with the randomness some are going outside, but it's not a problem. Okay. So yeah, next step, the growth. So the growth might be easier for us. It's only focused on the compute shader, but we would need to add various things. Okay, so first of all, the growth is based on the noise. So first thing first, we would need to add some util functions here in order to handle everything. So let's show that. Okay, so what kind of function do I need to add? I need to add some various thing I have in my util function, which is the easing, the mat, the matrix, because yeah, I will explain later, but yeah. And I'm not sure about the SDF operator, but let's say that. Okay, so I'm putting my easing HLSL function, my math function, which handles some various little math things, my matrix from angle axis. This is a way, because this might be interesting, because maybe we want during the growth rotating the shape, so it might be interesting to have something like that and not only like that, you know, something like that. And the noise. Okay, so now we have everything we want, and we can focus on the compute shader. Let's get rid of this and open our compute shader, which is here, and I need to put it here. Okay, so first thing first, I need to add some elements. So I would add the noise and the easing which I need. I would also, I'm not sure about the math. I think the math was really useful. Yeah, S min, S max. Okay, yeah, let's add the math. Okay, and we also add in the util right now the matrix from angle, because I think I would love to try this one. Okay, so basically I will make everything we've made previously. So first thing first, let's get a random number. Okay, so float. We also have, I think we already have a random number, so let's focus on the time. So let's say time management. No, it's a noise, so I don't need the time, so I only need to noise the things, so I don't know why I've used the time. So let's say a noise. Okay, noise scale. So I would need for the noise, let's say I will not use the maybe I will use the simplex noise, but I'm not sure about this one. Util noise. I have an S noise here which take a float 2, and I have an S noise here which take a float 3, so let's use this one. I also have a noise here, but let's use the simplex, but I'm not sure about the simplex. I think it might be might have an error. So let's say noise scale, this is equal to S noise. We could take the origin position. In fact, we could take the actual position as our input dot xyz plus the time, which is here. We could say float time scale, so the time will handle the way it's moving. Yeah, the time will handle that. Okay, so the time scale, let's use a lamp into the time scale, it might be better. So it would be a linear interpolation between let's say right now we want to scale the time between 0, 5 and 1 using the data.w value, which is a random value. Yeah, it's here. No, it's not here. Where is it? Yeah, it's here. Yeah. Okay, we also need some noise scale. Okay, which will be equal to 1. This is basically this, because by multiplying this noise scale we will have bigger hole on less hole. This is the idea. So this is the noise scale, and now we can compute a new float 3, which is the new scale, which will be equal to the min scale. Is that? I don't remember how I used this. Time scale, new scale. Yeah, I made this one. Yeah, of course. Of course, the scale is quite simple. It will be a linear interpolation between the scale. So I need to retrieve the scale. So O scale, which is a float 3, is of course a float 3 of the original scale at index 0, 0. Remember, the scale is diagonal in the matrix, so this would be 1, 1 and 2, 2. And the float 3 scale is basically equal to a linear interpolation between float 3 0, 0, 0 and this original scale, because we want to go from 0 to that, and using our little noise scale, which is this. And now we can create our matrix for the scale. So this will be the scale. I will name this new translate scale, new scale, size, let's say size. Okay, and it's a lep and not a lepre. Okay, and this is a float 4x4, and it has size 0, 0, 0, and I think this is it, and this is the 0. Okay, 0, 0, 0. The last one is always 1, 0, 0. So this is more like that, in fact. Okay. Okay. So dot z dot y dot x x redefinition at noise scale. Yeah, noise size would be better. I redefined this or not? Yeah, I've used the wrong name for the matrix. Forgot my semi. No. Made a mistake somewhere here. Okay, another mistake somewhere. Where is it? Float 4, scale, log scale 5. Let's doesn't exist. Oh, something has. Oh, yeah, I've moved my shader, that's why. Yeah. So, as we could see, everything is really too big. Not too big, but too fast. So we would need to put some value into it. So let's add some elements. Okay, compute shader param public float. It would be a range between 0 and 1, and this is the time scale. Public float noise scale, and this would be between 0 to, for example. Now time scale. Yeah, this is something like that. Okay, this would be a vector 2 for the time scale, because this is a min and a max. So vector 2 time scale, not the noise scale is this one, but not problem. Okay, so uniform float 2 time scale, uniform noise scale float. So this is it, and we will lap between this dot x and this dot y. Then we bind the time scale. Okay, and then we would bind the float, which is the noise scale, and this would be okay. Let's say the time scale is 0, 1, 0, 1, and the noise scale is 1. This is strange. Did we forgot to multiply? Yeah, we forgot to multiply the time by the time scale. That's why 0, 5, 0, 5. Okay. So now we have a simple growth model. We could also change to create. So now we are nearly done to the things we add on the processing sketch. We have nearly done. So yeah, you've seen why I didn't want to use the simplex noise. Sometimes we have some kind of edgy, yeah, we've seen some kind of an edge here where element seems to be going from 0 to 1 quickly. So this is why I didn't want to use this noise, and I think 0, 0, 5. Oh. So I will go with the simple noise I've already had, and I need to debug this noise. So for this I need to change this. Okay. Okay. It's better. Remember I forgot something on the simplex noise, which was it's going from -1, 1. We still see this little guy here, and I didn't like it, like this one here where it seems to be really big. So I will go back to that, and I think I will use this, and we will use in the util function a easing in order to set a symbol in outquad, for example, to just scale a little bit the noise, to add some easing on the noise. So looks like something better for me. Now we have some hole into it. If we want big hole, it's something like that, which is basically the system we wanted. But something is not good. As you might notice, we are following the same path for all the growth, but on our example it's not like that. On our example, I think we are growing faster on the y-axis, so we need to change that. I need to check something I didn't remember, but does the HLSL take linear interpolation with a vector 3 as an offset? Let HLSL. Oh yeah, it might be a vector. So the thing might be to have something like growing faster on the y-axis in order to give some kind of feeling that the plant is growing up and then expanding. So I need to change this. So I will say flow 3, which will be our growth vector, and it would be something like float growth xy, which is our noise not in out quad. Okay. And the noise, so xz, and the growth z would be a little bit different, because first of all I will use another in-out cubic, so it will grow faster, but with this it will have another curve, but not faster, but with the in-out cubic it will have another animation curve. Okay, but I will need to change this value, and to change this value I would use linear interpolation or not. I need to rescale something. I have something going from 0 to 1. And I want to be faster than that, so of course I need to take the fractional part of my noise size, multiply by a scalar. It will be better. So this is basically the noise size, because it starts at the same, but let's say multiply by a scalar, for example 2 times. Okay, so this is it, and the growth is now equal to a vec3 of the growth xz and the growth y and now let's put that into the proper value. So now growth is used here into the scale, and we retrieve the same thing we had in the previous system. Okay, so we have our base system. We have the growth, and now we can focus a little bit on something. So we can, let's say 0 0. Okay, first of all, we don't have any random rotation, as you could see. So it seems the shape are clearly on the same orientation. Look like, yeah, you see, all the small leaves are on the same orientation. So we could rotate on themselves the shape. Okay. I will need to add also, as I will rewrite this, I would add a new data structure, and I will need to know the origin rotation. But yeah, if I add some rotation, for example, okay, So now I have some random rotation, but as you could see, we have some of the shape which some of the elements which grow outside. So we need to retake this because we don't want to clearly rotate all over the shape. So maybe we can simply add a little arc here. So the rotation here, we take a random rotation here. So I think max R&D need to be transformed as a vector, because if it's a vector, we can change, we can have a rotation of 102 degree on the y-axis and less on the x and z axis. So I will transform that as a vector. Okay, so if how do I know the magnitude of the vector? For example, vector 3 magnitude read only. This is it. So if we have a magnitude of 1 of 0, if we have a magnitude which is bigger than 0, okay, we only use this, we don't need that. And now it would be a vector 3. Okay, so now the max rotation will be that, but let's say 0.25 on the other axis in order to avoid having some weird elements. Seems a little bit better to me. Let's get rid of this debug value. Okay. Another thing we need to add is that we need to add some, we need to remove the cutoff. So let's go back into the shader because it can be quickly made. Curl off. I think it's like that. I'm not sure. Yeah, it's like that or not. Let's see. Yeah, now we have some cutting, so it's better. So 25 is a little bit too big. Okay. Okay, and let's try to rotate a little bit, and if we can work with the rotate, we can see how we can bind everything to the proper value. So I don't remember which one has a rotation, but I think I would find one. We need a direction. Oh yeah, this is basically this. In fact, I need to get this vector, which is a quaternion, in order to get that. So let's try that. Let's try something like properties id dot x dot roadmat. I think this is the road math. Okay, and this would be equal to angle axis. So let's take the time by the time scale. Okay, so time multiplied by the time scale. Okay, so this is the angle. I want to rotate on the axis, which is the float 3 on the y-axis. Okay, so the up vector. And I don't want to have the shape rotating all over during the noise. Okay, so I think I will multiply it by the inverse. So all over the noise. I don't want the shape rotating all over time. So even if the growth is finished, I don't want it to rotate. Okay, so I only want to have something like that, not something. So I will need to have a new value, which will be float growth rot. Okay, and this would be boom 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 boom. It would be strange to have something. No, yeah. Let's keep the same thing as this one. I'm recomputing this value just because if I want to change the animation curve for this one, it might be interesting. So I'm taking the inverse. So when the noise is 0, which is 0 growth, it will be 1. So we will have a rotation at the beginning, and when the noise is 1, it will be 0 because it's inverted, so we would not have any rotation. So we have something like turning like that, and like that, and like that. Look like it's always working. So maybe I need to rescale also the noise. I forgot to say that I wanted the fractional part only to avoid that. I think I will do the same here. Oh, I haven't applied that. I multiplied by 1. So that's why we have the full rotation. Let's check a little bit something. So first of all, the rotation is not working, but and when I didn't change the rotation, there's some strange value sometime on the scale here. For example, some is okay, but some are not. because I'm taking the fractional part and not taking the okay, so this is the problem. Okay, so now it's not a problem. But when I activate that, of course I've lost the rotation. Looks like I'm rotating, but not enough. The rotation is not as easy as I thought because I'm redefining the rotation here. And I want to rotate around the pivot point, and this is clearly the full rotation of an object, so I will need to compute basically the correct rotation. Trying to think about it. We need the direction of the so okay, the up vector. Let's find something like that. Shader rotate. Shader model. Let's rotate along axis. Rotating mesh in vertex shader. This is what I want. Pivot rotation matrix. I would need the normal in order to rotate around, but right now let's not use this part. I will try to, I don't have it in my retake, so let's don't use this part. Okay. Last thing would be to change the color of the shape based on our little elements, our little so data.x based on the noise. So I would simply bind the noise here and take the flower here, and I would say this multiply by in dot data dot x. Okay, so this would be a way to create a simple let's check over the top. Okay, let's say 0, 1. Let's not let's put the same color for each of them just to be sure that we pass everything. I think I would need another noise because I put the same noise, so it's not good enough. So I would need to put something better like that. If I push, yeah. Something with another time scale, for example. Nice color. Okay. And let's offset this a little bit. So let's say, let's choose a random value. So now I would see something different, I think. Or not. Why? Let's don't push the scale here and try to just see the, yeah, I push the same value, that's why. I've pushed the same value, which means if I make this kind of mistake, it can be only meaning that this is the end of the stream. Okay, so now we see this. So I've offset it a little bit, but I need to put some time color scale, noise color scale, so I would add something different here. And the time is globally, so I don't want to add some randomness into it, or does I? I'm not sure. I think I don't want to put, I get something more uniform and not to disturb. Okay, and this would be that. And now let's add our two values, which are here: noise color scale and time color scale. Okay, put this here. It's the float. Noise color scale, noise color scale, time color scale, time color scale. Okay. Okay. 0.025. Okay. 0.025 and 0.25, I think. Okay. Now we are seeing the noise. So that's okay. Let's reactivate in the compute the scale. Let's check something on processing. So the sketch is nearly done. We only need but now to work on the shading, though the growth and the color evolution is basically here, even if I haven't used the ramp right now. I think I've used the ramp in my rendering in order to be sure, but I don't see any ramp. I don't remember how I push over the color, but so do we made a quick don't remember. Yeah, I think this is a did, but I'm not sure. Shape pass into VBO plus, and I will say the number of instances. How many instances do we have? Yeah, we have 3000 flower on this experiment, but on our own here we have I think we had a lot of them because we have 10,000, so that's why. Okay. So we can now play more with them. In our P5 we have nearly 3000, so if you want we can simply say that. Okay. Let's test something. So we have nearly done. No, it's okay. We have nearly done. So what we can do now is checking in this my shader. This is the frag, I think. I think the color. I didn't remember how I've put the color, but I don't see any noise somewhere. So the color might be defined in another way. Ah, yeah. Color is based on the 8. That's why. That's how I get this nice powerful color. Okay. Okay. Yeah, it's from 0 to 1, so I think I know. Yeah, I leapt from this. Okay, I think I could change this. Don't know yet how, but I think I would simply use a ramp. I will make it later. So the random on the pose it's done. So I think the shading is quite correct. I might want to try something else, but I'm not sure about that. We will focus on the shading I think tomorrow, but let's try another thing. I want to try back the GPU mesh instance. GPU mesh controller is here. I want to retry the rotation, and I'm not sure about this, but I want to try something. I will need to change the data structure, and I also would need to change the data structure here by adding after this rot math. Okay, and after that I would say rot math, and then here I will need to say rot math is equal to that. Okay. Let's say properties plot 4x4 rotation is equal to properties.y.rotmat multiply by, I'm not sure, but rotmat multiply by this, the angle we will say the time, and the flow 3010. I forgot something else. Rotmat here. Everything, yeah, and the rotation is clearly not interesting, so look like I've made my thing. So yeah, it was more like taking the origin and adding that. Yeah, okay. So this was the system. So now I can say that we want to grow to that. I know it's P, but let me just, okay. Don't remember my P values, so let's say P constant PGLSL. It will be working if we do that, but it's clearly not perfect. Sometimes the rotation seems to be... This is strange. This comes from that, but... Okay, so the rotation is clearly not perfect, but I will take it another way. And again, clearly this is not interesting. Okay, so we've done it. We have our little guy here. Made some few change, etc, etc. But basically we have everything, so I think tomorrow evening I will work on the shading. So I would need to put the color on. Maybe I want to add some wind into the flower in order to make some little moves inside the leaves. Adding some lights. I want to add a reflection probe, some light probes, also some post-FX, some global illumination, and I would need to push some value into the shader, create a new structure in order to compute the light probe data, and etc, etc. And we would need a new version of these elements running smoothly. And I think this will be the end. So yeah, thank you for following this stream, and I hope I will see you tomorrow for the second part. And goodbye, everyone.